now that we're moving along, we are getting closer to the place where we can finally start looking at code. And I argue it's actually probably fine that we haven't actually seen so much as a line of code. It's been mentioned in the book. So if you're reading along, I know what you're thinking. He's lying to me. I'm not lying, I'm simply obscuring. So we haven't seen a line of code yet. And before we get there, we kind of have to understand that programs, and I know that this is simplistic, is that programs are made of different programming languages. So this is 1.3 in the text. You can see over here, it is page 8. At least in my version, it's page 8. And the first thing I do want to point out is if we continue on a little bit down here, this is page 10 in section 1.3, we have a list of popular programming languages. Now, I will mention here that this is in no way, shape, or form a complete or exhaustive list of programming languages. This is really like a high breeze by of what the programming languages are. But as we go down this list, we go from what is known as a very low level programming language, something like BASIC. BASIC is what is known as low level because it interacts not directly with the hardware level of the computer, but it's very, very close to the hardware level, which we would think about as like the ground floor, the bottom basement, because it's right there next to the hardware. Hardware only understands zeros and ones in the same way that all programming languages really only understand zeros and ones. That much is true. But BASIC, Fortran, COBOL, and Pascal, all of those are low level. You have an opportunity to directly interface in some way, shape, or form with the machine level worth of the computer operating environment. C and C++ are kind of in that, and C Sharp are in that middle ground. It is a mixture of very low level and very high level programming. And that's what actually it turns out is an advantage to you as a developer. It's an advantage to, whomever the entity is, the organization or the groups of organizations are that have, hired you to put together a piece of software for them. There's this mixture of very, relatively close access to the hardware itself and some very, very high level features which make it easy for you to actually program. I know I have mentioned in the past in other videos, sometimes positively, sometimes not so positively, other languages like Python and Ruby and JavaScript. Even you could argue Visual Basic. And if you're going to say Visual Basic, you can kind of, out of the corner of your eye, you can see where Excel with its VBA integration is a little bit like a very, very high level programming language. Here in high level programming languages, you're very, very far away from that low level. You are about as far away from actually interfacing with the hardware. You need other layers to be able to do that. We teach here on campus at Rock Valley, we teach JavaScript and Python very much just inside of a browser. They need another environment with which to exist. They rely on, and we use Chrome because it's the easiest for the text editors that we use to code in JavaScript and Python. But without Chrome acting as the hardware intermediary, they wouldn't function the way that C++ does not need another program to act as a hardware intermediary. So again, that's part of the benefit and the charm here of using C++ is we've got this really unique mixture of low level and high level types of programming where that mixture in the middle really makes for speed, low overhead, high access volumes, high access speeds, and it runs really very, very quickly. Next, we'll break this 1.3 into two sections, and we'll look at, the steps in which we need to go through in order to actually run a C++ program.